Alright, we're back with the time value of money. Probably something you never thought about before. The value of money changes over time, and we know that due to inflation, but that is not what this video is about. So this unit, we are not talking about inflation. But there is a statement here, and that statement is that a dollar paid to you today is worth more than a dollar paid to you 1 year from now. So that starts off really simple. If I offered you $10 today or $10 1 year from today, you should pick the $10 today. But why? Well, at the same time, so this is the second statement, a dollar you must pay today is more burdensome than a dollar you must pay 1 year from now. So if I offered you have to pay me $10, you can either pay me today or you can pay me in 1 year, and it'll be exactly $10 either way. You should pick to pay me next year. And again, we're not talking about inflation here, so why? Well, we're going to have this calculation because we're going to determine the present value of money and the future value of money, because we want to be able to make comparisons to know, well, what if I offered you, so I say, all right, I'll give you $10 today, or if you wait 1 year, I will give you $12 instead. How do you make that decision? Or maybe you don't care because $10 and $12, that's small amounts of money. So I offer you $1 million today, or next year, if you wait a full year, you'll get $1.2 million. Should you wait, or should you take the money today? And to do that, there is a very important thing that we need to know, and that is the interest rate. Without knowing the interest rate, we cannot answer those questions. So the present value of a dollar realized 1 year from now, meaning that you get that dollar 1 year from today, is equal to that $1 divided by 1 plus R. R is the interest rate. It is the amount of money that you must save today in order to have $1 in 1 year. It is the value to you today of $1 realized 1 year from now. So what we're saying is present value is we're going to figure out, all right, if I give you $1 1 year from now, how much is that equal to right now today? So we can make that decision of whether or not to take the money that I offer you. So present value equals X dollars divided by 1 plus R, R being the interest rate. Okay, I know this sounds kind of convoluted. It's not that bad of an idea. So again, we're trying to see what is a dollar that you get a year from now, how much is its value currently today. So let's do an example. Let's put some numbers to this. If the interest rate is 10%, because remember, when you save money, the bank pays you an interest rate. That's what this whole thing is based on, is that you could be earning interest if you had that money today. Okay, so if the interest rate is 10%, what is the present value of $100 received 1 year from today? Hit pause and go ahead and calculate that using the formula that we just did. Hit pause. I told you, come on. Okay. All right, our answer. Well, we have our calculation, our formula. Present value is equal to X dollars divided by 1 plus the interest rate. So that's going to be $100 divided by 1 plus 0.1, 10%, 0.1. So it's $100 divided by 1.1, and that's going to equal $90.90. Why is that significant? Like, why does this matter at all? Well, because now we can answer the question. So if I offered you $95 today or $100 next year, which one should you take? All you have to do at that point is look and see, is that $95 more or less than the present value? And in this case, $95 is greater than the present value, so you should take the $95 today because you would have more than $100 a year from now if you save it. On the other hand, if I offer you $85 today or $100 next year, you should wait for that $100 next year, mathematically, because 85 is less than the present value. And if I offered you $90.90 today or $100 next year, the answer is it does not matter. You can pick whichever one you want because they are equal. So what that is telling us is that $90.90 today is equal to $100 in 1 year. All right, we can do the same thing with money realized 2 or more years in the future. It's the same exact formula, just putting the in there as the number of years as the exponent. So if you go, 2 years, 4 years, 10 years, you can do it however you want, and you just put the number of years as the exponent, and you can create the present value of money that you would receive, 5 years down the road or 20 years down the road. What's it worth today? Same exact thing. We can also do future value of money. Future value is pretty similar. Instead of dividing though, we're going to multiply. So future value is X dollars times 1 plus the interest rate. It is the future value of money obtained, that's the 2 years or more. And then the same thing, using the exponent, because we can look at money so we save money for you when you're a baby, and then when you're an old man, apparently that baby looks a little different when they get older. But so the baby started off young, and we look at the future value of its money when it is all grown up, and we'll use this calculation. So in this case, what we're doing is we're just working the other way. It's the same exact idea. I offer you $100 today. How much is that $100 expected to be worth based on the interest rate? Yeah, pretend like it says 5%. I'm going to edit this slide. You should know that this originally said 10%, and I edited it. All right, so if the interest rate is 5%, what is the future value in 1 year of $100 received today? So go ahead and pause that, calculate that, figure out your future value. All right, our answer, we're doing $100 times 1 plus 0.05, 5%. So it's $100 times 1.05, and it equals $105. So the future value of $100 given to you today in 1 year is $105. Future value is usually the easy one. Kind of one of the really easy ways to remember this is that the future value of money is going to be greater than what it is today. The present value of money in the future will be a smaller number. So if you're ever confused, like, do I divide or do I multiply? For future values, your number needs to be greater than the current. For present value, it needs to be smaller than the future. So one way to remember it. Net present value is the present value of current and future benefits minus the present value of current and future costs. So basically we use this term so that we can make those comparisons. So when you decide, should you take out this loan because it's going to cost this amount and this is what you could have had if you'd saved the money, blah, 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 you'd use net present value to figure it out. Current and future benefits minus current and future costs. If your benefits are greater than your costs, then you do it. If not, you don't do it. This has been a LaMoney production.